What if the very fabric of your visual world, everything you perceive, is nothing more than a grand illusion, meticulously crafted by invisible lines of energy? What if the light that paints our reality is constantly bending, bouncing, and reshaping the truth before it even reaches your eyes? For centuries, humanity has gazed upon the world, accepting what we see as absolute. Yet beneath the surface of our everyday experience lies a profound elegance, the science of ray optics. It's the story of light, not as a mysterious wave or a quantum particle, but as simple straight lines, rays, that obey surprisingly simple rules. Imagine light as an endless stream of tiny, perfectly straight arrows, launched from every point on every illuminated object. These arrows travel relentlessly forward until they encounter something in their path. This fundamental concept, that light travels in straight lines, is the bedrock of how we understand vision, photography, and even the cosmos. When these light rays strike a surface, one of two primary events occurs: reflection or refraction. Reflection is the bounce. Think of a billiard ball hitting the cushion. The angle it hits is the angle it leaves. This simple law governs everything from the mirror you look into each morning to the shimmering surface of a lake. But not all reflections are created equal. A perfectly smooth surface, like polished glass, gives us specular reflection, creating clear, sharp images. A rough surface, however, scatters light in every direction, a phenomenon called diffuse reflection, which is why you can see this page from any angle, but not your reflection in it. Then there's refraction, the bend. When light rays pass from one medium to another, say from air into water, they change speed. This change in speed causes the light to deviate from its straight path, bending at the interface. It's why a spoon in a glass of water appears broken, or why the bottom of a swimming pool looks shallower than it truly is. This bending is precisely what allows lenses to work their magic. A convex lens, thicker in the middle, converges parallel light rays to a single focal point, magnifying or focusing images. A concave lens, thinner in the middle, diverges light, spreading it out. These simple shapes manipulate light to create entirely new visual realities. The most extreme form of refraction is total internal reflection. When light tries to pass from a denser medium to a less dense one at a sufficiently steep angle, it can't escape. Instead, it reflects entirely back into the denser medium. This principle is the secret behind sparkling diamonds and the incredible efficiency of fiber optic cables. Ray optics isn't just an abstract concept. It's woven into the very fabric of our daily lives. Our eyes are sophisticated optical instruments, using a lens to focus light onto our retina, where it's converted into electrical signals our brain interprets as images. Without the principles of ray optics, we simply wouldn't see. Every photograph ever taken, every movie ever filmed, every microscopic discovery, and every distant galaxy observed through a telescope relies on the precise manipulation of light rays. From the simple magnifying glass to complex medical endoscopes, ray optics is the silent architect behind our technological vision. But here's the profound truth. The ray model of light, while incredibly powerful and predictive, is a simplification. Light is far more complex, exhibiting both wave-like and particle-like properties. Yet for understanding how lenses focus or how mirrors reflect, the ray model is a perfect, elegant approximation. It reveals that the universe, in its infinite complexity, often operates on beautifully simple underlying principles. The true marvel of ray optics isn't just its ability to explain how we see, but how it reveals the universe's elegant design. It shows us that even the most fundamental aspects of our reality are governed by rules that, once understood, unlock a deeper appreciation for the intricate dance of light. The world isn't just illuminated by light, it is, in a very real sense, constructed by it.